Okay, so why?
Because the slope is positive and then it switches, one goes horizontal, then goes to negative.
Okay, so this means that the slope is positive, this means the slope is negative. Okay, so we're going to say at x equals -2, because f prime of x switches from positive to negative. Are there any other places that happens? Doesn't look like it. All the other switches, well, the other switch occurs here. Okay. Alright, so that leads me to, for what values of x does f have a relative minimum? Because f prime of x switches from negative, and what that means is if the derivative is negative, that means the function is going down. It's got a negative slope, and then it switches to positive slope, and so that means that there would be a relative minimum there. So then what does this mean about f1? What happens? What happens at x equals 1? The slope is still 0 there, but it's not a sign change. It could be like, you know how in a cubing function how it looks, like where it levels off. But then it's negative actually, so the slope is negative, so it's going down, levels off, and then continues to go down. And this is going to be important because when we do D, when we do our sketch of a graph, we're going to want to show that. All right, now let's see how from Friday. How do I tell when the graph of f is concave up? If you need to cheat and look at your notes, you may do that.
F prime of x is increasing.
When you're given the derivative, because I'm not given the double derivative. It's when the double derivative is positive, but that means it's where f prime of x is increasing. And so when I'm answering this question, I'm going to find where is f prime of x increasing, so it looks like from there to there, right? And then also from here to there. Okay, so we're going to state those two intervals and then our reason. So from -1 to 1, and from 3 to 5. Why? Since f prime of x is increasing. Since f prime of x is increasing. Okay. Okay, so now what we're going to do is we're going to practice sketching a graph, and we're going to make sure we address concavity. We're going to make sure we address the slopes. So some things we want to keep in mind is at first the function is going to be, is this the right one? Yeah. I think it says from 0 to 2, right? Yeah. So we don't have to do the whole thing. From 0 to 2, is the function right here going to be going up or down?
Down.
Down, because the slope is negative. Then the slope's going to briefly be 0. Also, on the interval 0 to 1, it's going to be concave up. So we got to make sure it's got something like this going on. Okay. All right, then it levels off. It's still going down, correct? What's also happening here? Switches to concave down. By the way, that makes x equals 1 an inflection point, doesn't it? Okay. and then the function is still going down, then it's going to switch to going up. I don't think I have to address that though, right? Because I'm just doing 0 to 2. Okay, so let's graph from just 0 to 2. Are we told anything else?
F of 1 equals 0.
F of 1 equals 0. Okay. F of 1 equals 0. Let's put that on here, okay. And also the slope is also 0 there, right? Alright, so here we go. I don't know where it starts exactly. It doesn't tell you what F of 0 is, so I'm not sure, but what I'm going to do is I'm going to make sure that this is concave up. So I'm going to make it kind of have some, see how if I just curve it like this, it's concave up? And then I'm going to make it level off. Now I'm going to switch to, is it concave down? Something like that. So I addressed a couple things. I made the slope 0 here. I made this concave up and then concave down. And also, the entire time, the function was decreasing because f prime of x was below the x-axis, so it's negative. Okay, questions on that?